All right, this chapter, chapter 5, is on calling methods. Invoking, it means calling a method means to cause it to be executed. And it's the last chapter in the first part of this series of videos. Um, with this chapter, with after you cover this chapter, you really know everything you need to know to do a lot of interesting things with Java. Now we've only superficially covered object-oriented programming, which is a main component of Java. However, just writing loops and if statements and various types, primitive types, and so on and so forth. You already know you will know how to do all that, how to create programs that have multiple methods, and so on and so forth. So you can, by the end of chapter 5, do a lot of good stuff with Java. You might, if you're taking a math course, there might be computations that you could do um, by writing a Java program to do them rather than doing them by hand. Same thing with other subjects, such as physics or chemistry or statistics, business. Business frequent will business applications are many, and you might be able to write your own business application using Java. So if you are taking a course, or if you have an interest in some subject that has a mathematical component to it, you might want to just start using Java for real, trying to solve some problem that you're interested in. That certainly is going to enhance your understanding and appreciation of the Java programming language. All right, so let's start chapter here. Now, in order to call a method, you have the method name, and you always follow the method name by parentheses. So here, this is an example of a call of the method f, and we don't have anything inside parentheses, which means we're not providing the method with any items. We're just calling it. We're just causing it to be executed. All right. So you always got to have parentheses after the method name if you want to call the method. All right, so here is a program which consists of two methods. So we have a single class but two methods. And the name of this class is call1. So let's see, what does the main method do? And remember, it gets control first. It's going to execute first. Now I have the main method first, and then that's followed by the void method. But if I interchange the order, the main method would still be executed first. So they're not executed in the order in which you list them within a class. They're executed, main always goes first, and then what happens after that depends on what main does. So the first thing main does is display before call, and then line 6 we're calling F, right? We're calling F. So we go down to F, and the body of line F of the method F on line 12 displays in F. Then after we do the method, we go back to where we called it. So we called it at line 6. So when the F method finishes its thing, then you go back to line 7. You pick up right where you left off. All right, so from line 6, you go to line 10, 11, 12, 13. When you're finished with the F method, you pick up where you left off. We left off at 6, so you go back to line 7 and finish the main method. All right, so the output that this program is going to generate is before call, in F, after call. Now, how did we declare F? Well, we want it to be public, where we don't want it to be part of an object, so you say static. It doesn't return a value to main. All it does is it displays a string in F. So the return type is void because it doesn't return anything, so the return type is void. And F is the name of the method, and it doesn't have any parameters. So when F calls it on line 6, you don't put anything in the parentheses, and you don't have anything inside parentheses on line 10 either. All right. All right. All right. Now let's take a look at this program. This is a really important one. In this program, we're calling a method display sum. Main is calling display sum, and it passes it the values of 3 arguments, which are received by 3 parameters. And then those parameters are used in display sum. And the sum is computed, and then the value of the sum is displayed. All right, so let's take a look at line 6. We're invoking, you have a method name followed by parentheses, so we're calling the method, we're causing it to be executed, and you have 3 things inside parentheses. They're called arguments. All right. It's a little strange name, but that's common. That's frequently used in mathematics as well. Anyway, there are 3 arguments, and x is one argument. The second argument is x plus 5, and the third argument is the int constant 20. Now, the first thing that happens when you have line 6 executed, the first thing that happens is the computer will determine the value of each one of those arguments. So x has the value 1. It will determine that from the variable x. X plus 5, it will do that addition and get 6. And 20, of course, is just equal to 20. So it will determine those values. So those arguments have values 1, 6, and 20. All right, those are the values. So first, number 1, determine the values of the arguments. Number 2, you have on line 10, you have those parameters, right? A, B, and C. The next thing that's going to happen is those parameters, A, B, and C, are going to be created. A, B, and C don't exist until you call the method display sum. All right? First thing that happens, what was that? Determine the value of the arguments, so we get 1, 6, and 20. Second thing is the parameters A, B, and C will be created. Third thing is the values of the arguments will be automatically assigned to the corresponding parameters. So 1 is assigned to A, 6 is assigned to B, and 20 is assigned to C. All right. And we say we're passing, those values. We use the term passing. We're passing those values 1, 6, and 20 to the display sum. What's actually happening is that there's going to be 3 automatic assignment statements. 1 is going to be assigned to A, 6 assigned to B, and 20 is assigned to C. All right, and then what happens in display sum? Well, we declare a local variable sum. By the way, as I mentioned, A, B, and C don't exist until you call the method display sum. Same thing is true with the local variable sum on line 12. That doesn't exist until you call the method. So when the method is called, that's when the A, B, and C come into existence and are assigned values. And line 12, in the call, the actual call, line 12 is what is going to, in effect, create the variable, the local variable sum. Then line 13 just sums up those 3 values in A, B, C, the parameters A, B, and C. And we get 27, which is assigned to 20, which is assigned to sum. And then on line 14, we just display the value in sum preceded by the label sum equals. So you'll get out sum equals 27. Okay. Then after display sum is at the end there, it's going to return. The return process will destroy the A, B, C parameters in the local variable sum. So the only time the A, B, and C exist and sum exists is when you're actually in the process of executing the display sum method. When you're like on line 7 over here, right? Line 7, where you're displaying the string all done. When you're executing that, A, B, and C no longer exist, and sum no longer exists. The variable sum, which is declared on line 12, no longer exists. They are created. The parameters and the local variables are created when you call the method, and they're destroyed. And they're destroyed after the method, when the method returns to the caller. So sum, initially doesn't have any value, line 12, right? We're not initializing it, but then line 13 gives it a value, gives it 27. Then when display sum returns to the caller, sum goes away, so that 27 goes away. So if you were to call display sum a second time, sum initially on that second call is initially going to have nothing in it. It's going to be recreated and it will have nothing in it. Same thing with the parameters A, B, and C will get new values. So if you call it display sum a second time, passing it 1, 2, 3, A, B, and C will have 1, 2, or 3. It won't have those old values 1, 6, and 20. All right, very important you understand this. This is the basic mechanism of parameter passing that is used in method calls. So extremely, extremely important that you should understand that. So let me just review one more time. Line 6 inside parentheses, you have things that are called arguments. We got 3 arguments. And on line 20, you have the header of a method. Inside parentheses, you have things that are called parameters. A, B, and C are parameters. And the types of the parameters should be compatible with the types of the values of the arguments. So X is type int, so notice A is type int. You know, if X was a double and A was int, then that wouldn't work. You get a compile time error. That's incompatible. You can't pass a double to an int. All right, that's illegal. I'll say more about that in just a little bit. But if X were declared double and A is int, then that would not work. All right. So the first thing that happens in a method call is the arguments are evaluated. Second thing is the parameters are created. Third thing is the values of the arguments are automatically assigned to the corresponding parameters. Then you execute the body of the method. At the very beginning of this method, sum will be created. And then when the method finishes, this method will then return back to where it called it from. So it's going to return to line 7, right? The line 6 will be done on the return. So it will go back to right after the call, line 7. And that return process destroys the parameters that were created, A, B, and C, and the local variable. All right, that's it. Make sure you understand that. Okay, what happens during a method call? Well, in this past example, the parameters, whatever there are created. So in this previous example, we had A and B and C. They're created at the time the method is called. They don't exist before the method is called. And then the values of the arguments, you know, in the statement that calls it inside parentheses, going to have values there. And those values for the previous example were 1, 6, and 20. Those values are passed to the corresponding parameters in the method that's being called. That is, 1, 6, and 20 are automatically assigned to A, B, C, the corresponding parameters. Okay, now, inside this called method, there is a declaration of sum. And when you call the method, that's when sum comes into existence. It did not exist before you called the method. So you have the same thing with sum as you have with the parameters. The parameters are created only when you call the method. And the local variable, we call it local because it's right within the method. So the local variable, sum, is created, which is on line 12. It's created. Doesn't have any initial value, however. All right, then the body of display sum is executed. And there's a line 13 which computes the sum of A, B, and C and assigns the sum to the variable sum, which is named sum. And then line 14 displays that value. All right. So display sum doesn't return anything to main. It just does something like it. In this case, it just displays the computed sum. All right. Then the next step is that display is going to go back to main and pick up where it left off. But that process of returning to the caller, so main is the caller and display sum is the called method. The process of returning to the caller, that is when display sum goes back to main, both the local variable and the parameters a, b, and c are destroyed. They're gone. They don't exist anymore. All right, so a, b, c, the parameters, and the local variable sum are created when the method is called. And when the called method returns to its caller, those parameters, a, b, and c, and sum go away. They're destroyed. So if you were to call the method display sum a second time, a, b, and c will have whatever new values you pass it in the call, and sum will initially have nothing in it when the declaration is processed. All right. All right. Now here we have a slightly let's see. Here we have call 3, and all right. Well, let's just describe what's happening here. This is pretty much like the last one. We initialize x to 1, and then on line 6 we call display, and inside parentheses are x, x plus 5, and 20. Those are called arguments. X is an argument, x plus 5 is an argument, 20 is an argument. Now when you call when the computer executes line 6, it's going to determine the values of those 3 arguments. So x has the value of 1, x plus 5 has the value of 6, and 20 obviously has the value of 20. So the value of those 3 arguments are going to be 1, 6, and 20. All right. So when line 6 is executed, the first thing that happens is that the value of the arguments are computed. The next thing is that the corresponding parameters in the called method display are created. So right after the values are determined, 1, 6, and 20, then the parameters x, y, z are created. They don't exist before. And then after they're created, the arguments are assigned to the corresponding parameters. So the first argument, which has the value of 1, is assigned to x. The second argument, which has the value of 6, is assigned to the second parameter, which is y. And the third argument, which is 20, is assigned to the parameter z. All right, then we create, we declare sum. So at that point, you get a sum variable. It doesn't have anything in it. But then line 13 sums up x, y, and z and puts the result in sum. And then line 14 displays the sum. All right, so that's pretty straightforward. X, y, and z have the 3 numbers, 1, 6, and 20. So line 13 will just sum those up and place the result in the variable sum. And then line 14 displays sum equals whatever that sum was. All right. Okay, then display sum returns to the caller. But when that occurs, the variable sum will be destroyed. It goes away, and the x, y, and z parameters are destroyed as well. They go away. And then on line 7, it just displays all done. All right, now something is happening here that's a little different than the previous example, I think. And that's because we're using x on line 5, and we're using x on line 13. So we have the same name, but those are 2 different variables. All right, so there is an x variable in the main method, and there is a second x variable, which is a parameter, the parameter x, which is in the display sum method. So is this legal? I remember mentioning you can't declare x twice. It looks like we're declaring x twice here. We're declaring it in the parameter list on line 10 rather, and we're declaring it on line 5 as well. No, this is perfectly legal. And the reason why is when you declare a variable inside a method, then that method is known only with that variable is known only within that method. So you can't refer to that x if you're outside that method. So let's assume, for example, there was no x parameter in display sum. Let's say it was a, b, and c, and then sum said sum equals a plus b plus c. And let's say you try to access x in display sum. You try to access it from the x in main from display sum. It would not work because it's local. It's known only within that method. So we say it's local. Another way of describing this situation, we say its scope, S-C-O-P-E, its scope is just within the method in which it's declared. All right? So that means if the scope of that x on line 5 is just within that method, that means you can only refer to it in that method. So it doesn't hurt to have a parameter x in another method, or let's say a local variable x in another method. However, you can't have a parameter x and a local method in the same method, because then those two would conflict, because both of those have scope in that method. So let's say instead of sum, I had int x on line 12, then you would have a conflict. You have two x's in the same method, because both the parameter x and the local variable x in that case would have the same scope. So you would, anytime you refer to x within the display sum method, would be ambiguous, because you have two x's that are known to the display sum method. All right. So local variables and parameters have local scope, so they can be used only within their own method, and they're created when the method is called, and they're destroyed outside the method. And obviously, if you're outside, let's say the main method, if you're outside a method, you can't obviously access stuff that's destroyed when you're outside that method. However, when we come down here and display sum, we're not really outside this method. We're still in here. We just made this call, so we're still in here. So when you call display sum and come down to display sum, the x on line 5 still exists. All right. All right, now, let's say you have a method that starts with public static void g, and it has one parameter, int I. Now, we can call that method, as I've shown there, g parentheses 20. And why is that legal? Well, because 20 has type int, and I has type int. So when you call that method, 20 is going to be assigned to I, so you want I and 20 to have the same type. Now, if D is a double, then that would be illegal. You cannot assign a double to an int in a regular assignment statement. And the same rule applies here. When you are passing parameters to a called method, in effect, you are assigning the parameters to the arguments to the corresponding parameter. So in effect, we're taking the D and assigning it to I, but that's illegal. You can't assign D to I. Why? Because D, if it's a double, has a much bigger range than I, if I is int. However, you can use a cast to convert the value in D to int, and then that new value, which now is type int, then is compatible with the parameter int I. All right, now methods. We haven't had an example of this, but methods can return a value. And here we have an example, get sum, which returns a value. So when you call get sum, you're going to pass it 3 integers. And those 3 integers will be received by A, B, and C, the parameters A, B, and C. So when you call get sum, A, B, and C will be assigned 3 numbers, okay? And then line 13, we create sum. And then on line 14, we add up whatever numbers are in A, B, C and assign it to sum. Then line 15, this is something different. We use the return statement. We return whatever value is in sum. So that value is going to go back to the caller. Now, if you look at line 11, I don't say public static void. I use int because the value that's being returned, we are returning a value. If we weren't returning any value, you would use a return type of void. It would be public static void get some. But here we're returning a value. So you have to indicate on line 11 the type of the value being returned. We're returning something whose type is sum. So we have public static int get some. All right. All right, now let's turn our attention to main. So x is initialized on line 5 to 1 and y. So we have x and y. Y currently doesn't have any value. Local variables, if you don't initialize them to anything, do not have any value initially. All right, and then get some is the call of, on line 6 is the call of the get some method, and you have 3 arguments there: x plus 5, and 20. So x is 1, x plus 5 is 6, and 20 is 20, obviously. So the very first thing that's going to happen when line 6 is executed is the computer figure out the value of those 3 arguments. So it's going to be 1, 6, and 20. The next thing that's going to happen is that the parameters A, B, and C will be created, and then those values 1, 6, and 20 will be assigned to A, B, and C. So A, B, and C A will have 1, A will be assigned 1, B will be assigned 6, C will be assigned 20. All right. Then, the sum is computed, and the value, the sum would be 20 plus 5 plus 2, 27. So the value that's computed is going to be 27, and that value is returned to the caller. And it, in effect, on line 6, you see that whole right-hand side, which is the call. This is an assignment statement that has in its right-hand side of a method call. That return sum, which is 27, is going to, in effect, replace that whole right-hand side. So get some, left parentheses, x plus 5, just temporarily. It's not going to actually change the code. But you can think of it as changing that whole function call, replacing it with the sum that's returned by that function call. So that whole thing is going to be changed to 27, which is then assigned to y. And then on line 7, we display sum equals whatever's in y. So it's going to be sum equals 27. And then main ends by displaying all done. All right. So that's the essential stuff you have to know about returning a value. When you return a value, you have to indicate in the method header the return type. In this example, we're returning sum, which is type int. So we say public static int. And then when you return a value, that value, in effect, replaces the function call. And if the function call is in an assignment statement, the value returned, which in this example is 27, is then assigned to y because we have an assignment statement. If that call of getSum was inside a print line, then that value would be stored to the inside of the print line, and you would get displayed 27. So what happens to the return value depends on how you use it in the calling statement. So since here we're calling the method, and that's the right-hand side of an assignment statement, the value return gets assigned to the left-hand side, which is y. All right, now here we have a slight variation. Here I am doing pretty much the same thing as before, but I have a little bit of a slight complication. If you look at the getSum method, by the way, the name getSum suggests that I'm getting a sum from this method. It suggests that it's going to return a value. So I picked that name intentionally because it suggests what the method does. And it's always good to name methods that in some way suggest at least what the method does. Okay. So here when we call it, we're going to pass A, B, and C, the 3 parameters on line 10, 3 integer values. So in this case, A is again going to be 1, and then B is going to be 6, and C is going to be 20. And then what we're going to do is we're going to compute the sum of those and then have the A plus B plus C right in the return statement, which is perfectly legal. What will happen is the computer will first compute the result of that expression that follows return and just return that value. So in the previous example, we had sum equals A plus B plus C and then return sum. You could just say return A plus B plus C. All right, so that's perfectly fine. And, it saves, one statement. It's just one statement fewer. Now let's take a look at line 6. On line 6, I'm not assigning the value returned. I'm using it inside a print line statement. All right. So when that print line statement is executed, before the concatenation can occur, the getSum method is going to be called. And it's going to return, that will return 27. So the 27 in effect is going to replace that call there on line 6, the call of getSum. So in effect you have sum equals, and then the plus sign means concatenation, and then 27. The plus means concatenation because the left-hand operand is a string. The left-hand side is a string, and therefore it's going to be concatenation. So in effect, after the getSum returns a value, you have sum equals plus 27. So you have concatenation. You're going to get displayed sum equals 27. So you don't have to have a call of getSum in an assignment statement. You could use it in a print line like I've showed here. I mean, the only thing that anytime you call a function, a method, by the way, I'll use the term function for a method. Now, most programming languages refer to methods as functions. And so I'm very used to using the term function and not method. But the object-oriented programming languages like Java used the term method. They thought method was a better descriptor of what a method really is. In any case, so I might occasionally talk about functions. Just substitute method for a function. Anytime you call a method, anytime you call a method that returns a value, then obviously you're calling the method to get a value back from that method. You're calling that method to get a value back from it. So therefore, you should use that value in some way. If you don't use the value in that way, then it probably doesn't make sense to call the method. So in this example, we're using the value. It's going to be displayed by the print line. In the previous example, we were using it. We were assigning it to y, the value return. All right, now, method names can be overloaded. So in this program, this is just the main method in the program. I'm calling the O method, but actually in this program, as you will see, we have actually 5 distinct O methods. There are 5 distinct O methods. The first O method doesn't have any parameters at all. All right. So certainly the call of O on line 6 or 7 or 8 or 9 obviously aren't calling the one that has no parameters, right? And why is that? Well, if you have an argument, you got to have a matching parameter. So if you have no arguments, then the function, the method that you're calling should not have any parameters. And if you do have an argument, then you have to have matching parameters. So the first O method should not have any parameters since we don't have any arguments. The second O method should have one int parameter. The third O method should have one double parameter. The fourth O method, and you'll see all these in just a second, should have an int parameter that will receive 2, and then follow that by a double parameter, which is 2.0. And then the last O method should also have 2 parameters, but the double parameter should be first, and then the int parameter should be second. Now, when the compiler compiles these calls, these method calls, it's going to look in the other methods in the class, to determine which of the O methods is compatible, right? So there is one O method that has a double parameter followed by an int parameter, and obviously that's the one that line 9 should call. There's another one there that has just a single double parameter, and that's the one that O should call. That line 7 should call, that has 2.0. All right, so the compiler can figure that out. So we have the name O used in more than one way. So we say we're overloading the function name, the method name O. All right, just like in the previous chapter, I said that the plus sign is an overloaded operator because it has more than one meaning. If you have strings on both sides of the plus, it means concatenation. But if you have numbers on either side of the plus, it means addition. So we're overloading, in this example program, we're overloading the method name O. O can refer to any one of 5 different methods. They all have the name O, but they differ in terms of the number, order, or type of parameters. Okay, so let's go to the next slide, see what we got there. So here is the first O method. It doesn't have any parameters. So that's the one when you call O and you don't pass it any arguments, this is the one that's on line 12 is going to be called. And then the one that passes just a single int, you will call the method, the O method on line 17. And then continuing, this is the one that's going to be called, the one that's on line 22 is going to be the one that's called by the call that has a single double argument. And then on line 27 is the method that's going to be called by the call that has an int argument followed by a double argument, 2 and then 2.0, right? And then this last one on line 32, that's the one that's going to be called by the method call that has a double argument and an int argument following that, because that matches these two parameters. So all these things differ in terms of order of parameters, like these last two. Are different in the order. They both have an int and a double, but the order is different. So the compiler can determine which one you want to call. And you have this one here, the double D, and then you have one that has int I. So they both have one parameter, but the type. So the order and the type, and then the number as well. So you have 0 or 1 or 2. So all three of those, if they distinguish by number and or order and or type, then you can overload the function names, because the compiler will be able to distinguish them by looking at the parameters and comparing it with the arguments. Okay, this is the last thing you need to know about method calls. So there are two kinds of calls, external and internal. Internal is when you have a call that's calling something in the same class. So for example, let's take a look at line 19. You see, that's in a class. This is, by the way, their first two class program. We have a class 1 and a class 2. This program consists of two distinct classes. Anyway, line 19 is a method call. It's calling display. And display is right there on line 22. It's in the same class. So that's called an internal call. And then if you look on line 5, it's calling add. And add, where is add? Add is in the other class, right? So the call of add on line 5 is an external call, because the add method it's calling is in another class. Okay. Now let's say I'm teaching a class and there's a student sitting in the front row named Bert, and I want to call on him. All right, so I would just say Bert. I just use his name. That's it. There wouldn't be any ambiguity because I have a Bert. Now, if I had more than one Bert, that would be a problem. But let's assume we have just one Bert in my class. I just say, hey, Bert, what's the answer to this problem? Whatever. However, if I wanted to call the Bert in the class across the hall, I would have to go across the hall, do something special to access that Bert because it's not in my class. I would have to, somehow indicate a Bert in the other class. I would have to somehow qualify my calling Bert to indicate that it's not the Bert in this class, my own class, but it's in another class. And that's exactly what you have to do with external and internal calls and accesses. So notice that this internal call on line 19, I'm just using the method name display. And the compiler is going to see that there's a display method in that class, so it knows that you're just calling that one. It's going to assume that's the one you're going to call. So you don't in any way have to qualify the call of display in line 19. However, the add method call, the call on line 5, that's an external call. So you have to qualify that. You have to qualify it by preceding it with the class that contains the add method. If it's an external call, it's in another class, you have to indicate in the call itself the class that contains that add method. You might have 10 classes that each have an add method. So if it's an external call, you have to, regardless whether you have 10 or if you have just one, like in this example, you have to qualify the call, an external call, with the class of the method. So you see on line 5, I say to.add. That means call the add method in the to class. So it's going to go down to line 15 and invoke that one. All right. So external calls of methods have to be qualified with the class name. All right. External calls have to be qualified. That means you have to add that to the function call. You have to explicitly indicate the class, the function, the method that you're calling is in. Now we also have a similar situation for X. All right, so let's see. X is on line 13, I'm declaring X. By the way, this is a new type of variable that we haven't seen before because it has the keyword static. But let me postpone talking about static right there and just finish this discussion of external calls and internal calls and accesses. Anyway, X is in that class. And well, let me just say this. X it's not a local variable. It's called a static variable. And its scope is the entire class. So you can refer to X in the add method. You could also refer to it in the display method. All right, because it's declared outside methods, it can be used in any of those methods. Now, if X were declared inside add, then you could only use it in add. You couldn't use it in display. If X were declared only in display, you could only use it in display. You couldn't use it in add. But X is declared outside both. It's a static variable. Therefore, its scope is the entire class. So we're using X on line 18. We're also using X on line 24. And I am accessing X. Those are just internal accesses, right? Like on line 18, I'm accessing X, and X is in the same class. X is up there on line 13. They're both the access of X and the declaration of X are in class 2. All right. So that's a internal call, and you don't have to qualify it. Notice I'm just using on line 18, X is assigned X is plus Y, and on line 24, I am just using X there as well. However, on line 6, okay, on line 6, I am accessing X, which is in class 2, in another class. So just like external method calls, you have to access with the class name. You also have to access on line 6. You have to qualify the X with the class name. So to.x means you want to access the X in the to class. If you just say X there, it's not going to work. It's going to expect X to be in the main method, and there's no X there, so you get a compile time error. All right, now let's talk a little bit more about line 13. Call that a static method. Static methods, they are always they're inside a class, but they're outside any method in that class. You know, like line 13, it's not inside the add class, the add method, nor is it inside the display method. It's outside all the methods in class 2. So that's one, and then it has the keyword static. All right. By the way, it starts with the keyword public, right? Okay. You know what that means? That means there's no restrictions on its access. I can access it from class 1. If I didn't have public there, if I had the keyword private, then line 6 would be illegal. The compiler won't allow me to access X if it's declared private. Same thing with the add method. The add method is declared on line 15 to be public. Line 5 would be illegal if I change public to private. All right, that's what I mean restricted access. If you say something is private, you can only refer to it in its own class. That's basically how it works. But if it's public, you can refer to methods and variables from some other class. All right. Now, line 17, you have a local variable y. That y will come into existence when the add method is called. When the add method returns to its caller, the y goes away. That's how local variables work. Local variables are declared within a method. They're created when the method is called and destroyed when the method returns to its caller. All right? Now that's distinct from line 13. Line 13 is not a local method, a local variable. It's, the X is not a local variable. It's a static variable. All right? And static variables are always declared outside all the methods. And what's very distinct about a static method as opposed to a local method like y is that static methods are there at the very beginning of the program. They're not created and then destroyed and created and destroyed like y is. Y is created when you call add, and then when you leave add and return to the caller, y is destroyed. All right? They're created, actually they're created even before the program is executed, and they stay in existence during the entire time. So that's very different than local variables. Local variables are destroyed when the method is called, are created when a method is called and destroyed when the method returns. Static variables are in existence throughout the entire execution of the program. All right, so X exists. It's initially 1 and it will stay 1 unless you change its value. Notice on line 18 we'll change its value. We're going to be adding 2, so X is going to go up to 3 when line 18 is executed. So it doesn't have to keep the value you initialize it. It can change. And of course we could change it up here if we wanted to in the main method. We could say 2.x equals 2.x plus 10, and that would change it as well. All right, so we now have integer variables. We have parameters, which are like a special type of variables, and we have static variables. Now, the nice thing about a static variable is that, let's say we, like on line 18, let's say main calls add, all right? And then what does add do? It adds 2 to x, so x goes up to 3. All right, and you get out. And let's say we call it a second time. You might want to try this. This program is in the software package, so you can try it. You don't have to type it in. Let's say you call it a second time. Guess what? When you enter add the second time, x is whatever value you left in there. So you left in there 3, right? So line 18 is now going to take 3 from x and 2 in y, and add those two together and assign 5 to x. So the values of static variables are retained between calls. Whereas that's never occurs with local variables, because local variables, when you return to the caller, they get all destroyed. The value is lost. So when you go in there, you don't get, you don't have whatever value is left in there by the last call. So that's a very important distinction between static and local variables. Static variables retain their value. They're there throughout the entire execution of the program. You put something in there, it's going to stay there unless you change it at some point. And then that new value, will stay in there until you again change it. All right? Very important distinction. Now, sometimes it's important to have a method that retains some value between calls. So in that case, you would definitely use a static variable. All right, this is a simple program to understand, but it illustrates some very important features of calling methods. And so you should study this, make sure you really understand it. I would suggest playing with it. Maybe, after studying it, then put it aside and try to write it yourself. Really try to understand this thoroughly, so that it becomes second nature as we get into more complicated stuff in subsequent chapters. It really is essential that you have mastered really thoroughly chapters 1 through 5.